Hey everybody, today we're going to talk about the idea of terminal velocity. So let's first define what terminal velocity is. It's the maximum velocity of a dropped object. So when objects are dropped on Earth, they speed up. But eventually they hit a top speed and they don't speed up anymore. They keep falling, but they don't get any faster. And every object is a little different. So each object has a different top speed. A skydiver could speed up as they're falling and eventually hit 120 miles per hour, but they can't get fast enough to be moving 130. Okay, once they hit 120 miles per hour, they don't get any faster. They stay falling at 120 until they pull their parachute. Whereas a feather might fall and speed up, but it only gets to like 5 miles per hour of speed, and it doesn't get any faster at that point. Okay, so every object hits what we call a terminal velocity, a top speed, a maximum velocity for a dropped object, and it's different for each object. Okay, so we need to be able to draw strobe photos of objects that are dropped. So when you first drop something, it accelerates, and that's what this part of the strobe photo is showing. How do we know it's showing that? Because the spacing, that's right, the spacing is increasing, so that's acceleration. But what I did was I took this last distance here, and after that I drew a line to show, hey, after that point it stops accelerating. It has hit its top speed. So this distance, I continued that same spacing down. So this, after the line, after the dotted line, I have equal spacing. Why? Why do I have equal spacing? Because this section here is constant velocity. So when you drop something, the strobe photo has increasing spacing, and then whatever the last spacing is, from that it increases to, you keep that spacing going after a dotted line to show, hey, after that dotted line it stopped accelerating and it kept that spacing and it kept a constant velocity. Okay, so that is what the strobe photo for any dropped object looks like: increasing spacing and then equal spacing throughout. And don't make the equal spacing equal to like the distance of the first two. Make the equal spacing equal to the distance of the last spacing from acceleration. Okay, so we're gonna draw, hopefully you copied this down already, okay? So I'm gonna erase that definition so I could have some extra room here. Okay, I'm gonna extend this dotted line a little bit. And down here, I wanna draw some force diagrams, okay? So what forces act on an object as it drops? And these force diagrams are going to explain, hey, why does it hit a terminal velocity? Why do we stop getting faster when we hit that top speed and we stay at that top speed? So what forces are acting on an object? Well, you watched the video of the skydiver, and there was the green arrow down, which stood for the force of gravity. So Fg, what is Fg? It's the force of gravity. That's the Earth pulling an object downwards towards the Earth. Okay, so I'm gonna make that arrow just a bit longer. You'll see why later. So there's the force of gravity. Now, as it starts to speed up, there gets to be a little red arrow from the video you watched pushing upwards. I'm going to draw that arrow shorter. The force of air resistance, F air, I call it. Force of air resistance. So that keeps it from speeding up too much. Okay? Now, when it's accelerating, gravity is a longer arrow than air resistance, meaning gravity is a stronger force than air resistance, which means because the downward force is more, it's going to actually, downward force is more than the upward force, that means it's going to speed up. It's getting faster, okay? But as it speeds up, remember, like when you stick your hand outside the window of a car, as you speed up, there's more air resistance on your hand. And the same thing happens to dropped objects. As they get faster, as they accelerate during the first part of their drop, the air resistance arrow gets longer, meaning the air resistance is getting stronger. And eventually, when it gets that dotted line there, the rest of its travel, the air resistance got so strong and got to be a longer arrow that the arrows for air resistance and gravity are the same length. What does that mean? That means that the air resistance is equal to the force of gravity. And those forces, because they're equal, we call them balanced. Meaning gravity is not stronger, air resistance is not stronger, they're just as strong as each other. Okay, so that means that it stopped speeding up. If gravity was still stronger than air resistance, then it would still speed up. If air resistance was stronger than gravity, it would slow down. But since they are equal to each other, air resistance equals gravity, it stays at a constant speed for the rest of its fall. And the constant speed that it stays at is called its terminal velocity. It's the top speed that it hits, okay? And it's not going to get any faster than that top speed.